Hello everyone, welcome to Hydrology Hub, your trusted channel for hydrology, water resources modeling and disaster management. In today's video, we will learn rainfall runoff modeling using HEC-HMS, which is one of the most widely used hydrological modeling tools. By the end of this video, you will understand how to build a rainfall runoff model in HEC-HMS and how to run the simulation and interpret the hydrograph. So let's begin. Here in this example, we will consider the loss method as SCS-CN method and the transform method as SCS unit hydrograph method, and base flow will compute from the constant monthly method and channel routing from the Muskingum method. Basin area we are considering as 500 square kilometer of the and loss method, as I mentioned, it's SCS-CN method, and here we will consider curve number as 67. And in transformation method, SCS-UH, we will consider lag time as 90 minutes. Base flow, constant monthly base flow as 2 meter cube per second for each month. Then in case of the channel routing in the reach, we'll consider the Muskingum routing where the Muskingum parameters k and x are k is equal to 1 r and x is equal to 0.2. And control specification will take simulation period from 1st January 2000 00 hours to 2nd January 2000 00 hours. And the time interval of the data is 1 hour. So first of all, open the HEC-HMS. So once you will open the HEC-HMS, you will get this window. So here in this window, go to the file, then create a new project. Click on new. Now give the name of the project. Here I am giving rainfall RR underscore model underscore HEC-HMS. Okay. So this is the model I have created. So now you can see on the left hand side, your model name has come up. Okay. Now go to the components. First of all, go to the basin model manager, click over here and then create a new basin model manager. So by default, it says the name as basin 1. So you can change this name. Okay, I am taking this name only. So create, close this one. Now expand this basin model, click on the basin one. So you'll find this new window has come up. So here you can create your basin model. So first of all, I'll create a sub-basin over there. So this sub-basin, again by default it has given the name as sub-basin 1. I'll take the same name, otherwise you can give any name. Then I'll connect this sub-basin with a reach. So this reach I'll create a reach over there. So now this reach has been created and the name has been given as reach 1. I'll take the default name, reach 1. Then I'll link this reach to sink. Click on the sink and then create the sink. So sink 1 has created. So now these are the basin creation tools are there. You can utilize these tools to create the basin. Okay. So now I have created this basin. Now the next step is that you go to the basin 1, expand this, then I've selected the sub-basin 1. Once you have selected the sub-basin, so here in the editing window, you can find you have to provide various parameters for the sub-basin 1. So first of all, it asks about the what is the downstream of this sub-basin. So I'll select what is the downstream of the sub-basin. So the sub-basin is connected with the reach 1. So I'll select the reach 1. What is the area of sub-basin? Suppose it's 500 square kilometer I have given. Okay. Then you can provide various information like the latitude, longitude to show on the map. Okay. Then the other parameters like canopy method and other method. Right now I am taking a simple rainfall runoff model. So I'll select the loss method here. So I'll select loss method at SCS method. Then another one is the transformation method. So here again I'll select the SCS unit hydrograph method. Okay. And then you provide the base flow method, which base flow method you want to take. So here I'll take the constant monthly values. Okay, so constant monthly I have taken. Now go to the loss and then provide the values over there. So the curve number value I am giving here as 67. Okay, and initial abstraction I have not given anything, and the impervious area also I have not given. Then the transform, in the transform give the lag time. Suppose lag time is 90 minutes. So you can, suppose your lag time is 90 minutes, you can provide the lag time in minute it is saying. So I'll provide lag time as 90 minutes. 90 minutes. Okay. Then base flow, as I mentioned that I'm taking the constant base flow, although in practical it is not like that. So you can provide the actual base flow. So I'm taking 2 meter per cube per second as monthly base flow. So 2 I'll provide for each month. I'll provide 2 2 2. So this way you can provide the base flow values. Okay. Now I'll go to the reach one. In the reach one, it is asking what is the downstream of the reach one. So in the downstream is the sink one. I'll connect reach one to the sink. So basically what I did, I connected sub-basin model to the reach. So water from the sub-basin is coming to the reach, and from reach to the sink. Okay. So the from reach I will connect the sink. Okay. And what routing method you are using? So I am taking routing method as Muskingum method. Yes. And then come to the routing parameters, provide the routing parameter k and x for the Muskingum. So k is 1.0, suppose, and x is 0.2. I'll provide. Okay. So this way I provided the values of the k and x. So now first part is my over. I provide all the data for the basin model. Now go to the component again and come to the time series data manager. I'll provide the time series data, means the rainfall data or the precipitation data. So I'll select the precipitation data, new. So as it has given name as gauge 1, I'll write gauge 1 underscore precipitation, so that I can understand that what type of data is there. So create this one, close. Now expand time series data, precipitation data. Okay. Now select the precipitation. So here in this one, I am selecting this incremental in millimeters, and the time interval is 1 hour. Okay. And then you select here, then you'll find the start time, start date, end date, and time. Okay, I am taking by default these values: 1st January 2000 00 hours to 2nd January 2000 00 hours. So whatever the data you have, accordingly you can set the date and time over here. So you can have this one. Now it will create the 24 hours because my time period is 1 hour. So it will create a table at 1 hour interval from 1st January 2000 to 2nd January 2000. So I'll provide the rainfall data. Suppose rainfall data is 20 here, 60, 90, then 12, 5, then 0, 0, 0, 0, 0, 0, 0, 0. Then again some storm has come, 5, 35, 48, 55, or 31, 20, 0, 0, 5, 0, 0, 0, 0, 0. Okay. So this is, now you can see the graph of this hydrograph. You can provide, this is the rainfall hydrograph graph is here. Okay. So now you have entered the time series data. You have created the basin model. Now the next part is that you go to the, there are various models are there. Okay. So you go to the control specification manager. Okay. In the control specification, new control one, I'll create control one. Okay. Then in control 1, again, expand the control model over there. Select the control 1. So it will ask the start date and time and end date and time. So my start date was 01 Jan 2000 and time was 00 hours. Then 01 Jan 02 Jan 02 January 2000 and date is 00 hours and time interval is 1 hour. Always remember that you have to correctly select the time interval of the data. Okay. So this way we have created the control parameters. Okay. So basically it will control the all simulation process. Now next is again go to the components. So you select the meteorological model manager. Okay. In the meteorological model manager, create a new model manager, Met1, create, close this one. Okay. So your meteorological model has been created. Now expand this one, go to the Met1. Okay. So here in this one, this has been created. Now go to the basins and select the basin. Say yes, I want to link the model with the basin. Okay. Then come over here, specify the head hydrograph. So with the sub-basin one, which hydrograph you want to connect. So I want to connect this. So suppose there in your case, there are number of rain gauges are there. So you can connect a specific rain gauge with a specific sub-basin. Okay. So I have linked this one. Okay. Once the model is created, so here you can see there are 4 components: basin model, then the meteorological model, control specifications, and the time series data. So all the 4 we have created. And after that, once you have created the model, go to the compute, then create compute, and then select the simulation run. So here the simulation run name will appear. So automatically by default it will take some name. I have already run the model previously. So the earlier model run was run 1, and now it is being run 2. So go here to the next, develop the run model. Okay, it will take the basin 1, then meteorological 1. It will link all those things. Okay, and the control it will link. So it has created the model. Run. Now select from here run 2, and then you just have here, I'll select run 2 here. Okay, and then run this model by clicking here. Okay, so the model has been successfully run. Close this window, go to the results, then in the results select run 2. Run 2 is your model results are there. You can see the global summary. This is the global summary. Okay, you can see the report of the global summary. What are the area and other parameters. Okay, and what is the peak discharge. It is showing all those things. Then go to the sub-basin 1. So it will show you the sub-basin 1 results, like the graph of the hydrograph over there. Okay, you can see the summary table of the sub-basin 1. Then the time series table. Okay, it shows the time, precipitation, what are the losses are there, excess rainfall is there, direct flow, runoff. Then the base flow, as we have taken the 2 meter cube per second as a constant base flow, so it will add the constant base flow, and the total flow it will show. So likewise you can see. Similarly, you can see at each one what is the graph or flood hydrograph. So you can see this is the inflow hydrograph and this is the outflow hydrograph. So the once the flood is routed in the channel, so this is the attenuation you can see in the flood peaks. Okay, so this you can see. Then you can see the result at the sink one, at the outlet. What are the results? So here in the outlet, all these results, and you can see the summary table. All those results you can analyze. So thank you very much for watching the video, and I request you to subscribe the channel for more informative videos on hydrology and hydrodynamic modeling. Thank you very much.